Hello and welcome to this tutorial after a long time. So today we are here because we want to implement KMeans clustering algorithm, and we'll do that using Python programming language, and I'm using Spider ID as my Python ID here. There are several options, several availability of other IDs as well, like PyCharm, idle, where apparently PyCharm is the most popular one. But let's say I'm pretty much familiar with Spider, so that's okay for me. Yeah. So for Spider, when you are working with Spider, you have one thing to consider, and that is your working directory, which is this, and it explicitly works as your root directory. Yeah. So it deals with the files you keep in its working directory. Let's say we'll be dealing with churn modeling, so you need to put churn modeling dataset on this working directory if you really want your script to find this dataset. Yeah. So yeah, churn modeling, this is the dataset we'll be dealing with today. And in the first place, I'm going to explain what is this dataset about and what's the business behind it. Yeah. So this is the dataset of a bank where you have several customers with some informations, and we'll be using this dataset for our clustering problem today. But I'd like to tell you that you also can use this dataset to solve classification problems as well. You can see this particular attribute existed, so it says whether a customer left the bank or not. Yeah, so pretty much convenient if you really want to use this dataset, and if you really want to pass this dataset on over a classification algorithm, that's completely fine if you consider this as a label. Yeah, there you can also pick other attributes as labels. That's particularly your choice, but this is the kind of dataset which was designed in a way that you can smoothly work considering existed as your class label. Yeah. So let's talk about the attributes we are gonna deal with to generate our clusters today. So we have credit score, which is a scoring unit that says that is generated upon your usage of the card, your transactions, the maximum amount of transaction you do at a time. So it's based on it's generated by some internal function of the bank, so we don't need to know that. So there is our credit score that is generated by analyzing the usage of the account, the usage of the account, let's say. Then now we have the balance of each customer in their account, and we have some estimated salary. Yeah, that's also some internal function of the bank that generates this number. Yeah. So today we'll be considering credit score, balance, and estimated salary to generate our cluster. But first, we would like to stick to just two of the dimension, balance and estimated salary. So the problem domain is going to be, we will consider the balance and the estimated salary and try to figure out how many groups are there of customers. We want to see the number of groups and how homogeneous these groups are and what information we find out of these groups. Yeah. So eventually, as we go far with this tutorial, you'll get to know how can we extract information from our generated cluster. Yeah. All right, so let's get started. First, you have to import some libraries like numpy, pandas, matplotlib. So I'm going to import them. Import numpy as np, import matplotlib dot pyplot, that's for drawing graphs, as plot. These things will be used as variables or as objects, you can say. We'll call different functions of this library using these objects or variables. And then yeah, pandas library. Yep. So first we have to import the dataset from our working directory. So as this working directory is considered as root directory, we can directly import that, and this is to be done using pandas. Yeah. So I'll put my instance of the dataset here, and pd dot, as this is a CSV file, there is a function read CSV, and here inside the curly braces you put the name of the dataset. Yeah. So select all the lines and run selection or current line. Oops, I'm sorry, run. Oh, it cannot find the file. Okay, maybe. Yep. So I've set this one as working directory. I forgot to do that. This should be fine now. Yep. All right, so we have imported the data set. So the next thing we are going to do is to extract the attributes we are going to work on, right? So let's take a variable x, and out of this data set, and one thing, you can also track your global variables from here. As you can see, dataset, the whole dataset is here inside this variable. So out of this dataset, we are interested in balance and estimated salary for now. Yeah. So let's just extract it, and that is done by using ilog function. Now you have two things to put here. First, what rows you want to include and what columns you want to include. Yeah, so we want to include all the rows over here, but we are not interested in all the columns, right? So it's only balance and estimated salary. So it starts from here with index 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Balance is in 8, 9, 10, 11, 12. And estimated salary is in 12. Yeah. So this sign means we are taking everything. Yeah. So we are taking all the rows but not all the columns. So two particular columns here, 8 and 12. Yeah, which is balance and estimated salary. So let's execute this line. Yep, should be okay. So done with importing that data set, done with extracting attributes we are interested in. Now what's next? The next job is to find out how many clusters we want to generate, how many clusters should be ideal for this data set and for these attributes. Yeah, so if you remember from the previous section, I'd like to open the PDF. Yeah, it's already there. We had a problem with K-means clustering, and that was how to determine the number of clusters. And to solve that, we used one technique where we experimentally took number of clusters through x-axis and the sum of squared errors through y-axis, or sum of distances from the considered cluster center and the closest cluster centers. Yeah, this could be anything, but ideally this is sum of squared error, and we keep tracking the values, and whenever we see this kind of fluctuation of value where there is an angle, or where there is basically an angle, we consider that number as our number of clusters for specific problem domain. Yeah, this is called elbow method. So we'll be using elbow method in our problem to come up with the optimal number of clusters in this case. Yeah, so let's check that out. So this section was about importing data set. Now we want to find the number of so here as you saw, they generated in this figure, they generated 14 clusters. Yeah, so what you do for one cluster, what was the sum of the squared, what was the value of the sum of the square error? For 2 clusters, for 4 clusters, 6, 8, 10. So this is how the whole chart is generated. Yeah, so here we'll do it for, let's say, 15. Yeah, we'll do it for 15. So we'll keep the sum of square values in an array, which is ideally called WCSS. Yeah, and as we want to do this test over 15 clusters starting from 1, let's run a loop. For I in range 1 to 16, because 16, the index 16 is excluded from this range. It'll start from 1 and it'll stop exactly at 15. Yeah, so here we write the code for generating our K-means cluster for different number of clusters, and for that we have to import one library that is sklearn dot from sklearn dot cluster package import nothing comes up. Yeah, all right, so we have imported the KMeans class. Now we'll use that. Yeah, so this is the object which is being initialized by this class, and it will receive some particular parameters, and we'll try to find out what parameter it accepts. Yeah, so we have in clusters init method in underscore init. So not all the parameters are equally useful or equally important in this case. So the first thing we want to do is in underscore clusters, which is going to be I, because in each iteration we want to increase the number of clusters, and for that particular situation we want to find out the sum of squared error. Yeah, so that's the first thing. And then second thing, the init method, which could be random maybe, but that's really problematic. There is one method, KMeans plus plus, which is ideal in this case, so let's keep it that way. KMeans plus plus. Yeah, and then the next parameter is in underscore init max iteration. No, we don't need them. Random state. Yeah, yep, so we are all set to go. Let's see if this is working, if we have any error in this line. Name KMeans is not defined. All right, should not be the case. It's already imported, but what's the problem? Oop, I did not execute this line, my bad. All right, now this should work. Actually, you don't have to compile or execute the whole thing line by line. You can do it all together, but just for the sake of two different graph plots, you have to individually execute your code sections for this particular project, and you'll get to know why. Yeah, so that's fine. Now I have this KMeans variable which is initiated by this class using these parameters. Now I have to fit my data using this variable. Yeah, now that is really simple. KMeans dot fit, yeah, x. that's where we are. So we are done, and what we do, whatever we get here, we want to extract only one information, and that is the sum of square error, or maybe some other distance measure. Yeah, oops. And that is done by, we want to append that value on this list, and that is done by KMeans dot inertia. So what is this, what this property is about? Let's figure out. Yeah, KMeans. Not sure. Yep, should be here. Yeah, here it goes, inertia. So the sum of distances of samples to their closed cluster centers. I think this is not sum of square error, but when you have 5 clusters, let's say, and you are considering one particular cluster at a point of time, and when you are considering that particular cluster, you just want to consider its closest cluster, and you find out the distance among those cluster centers, and finally you sum them up. Yeah, so this is what this property is doing. It's returning me the value of sum of distances of samples to their closest cluster center, and I'm appending those values in WCSS list. All right. Yeah, now I want to make some visualization, because the elbow method, the decision is to be taken by visualizing the graph. Yeah, the number of cluster versus WCSS graph. Yeah, so let's do that. We'll use plot for that. Plot dot plot. This is, yeah, range 1 to 16, because that's the x-axis, number of clusters, as you saw in this document. Yeah, the number of cluster is the x-axis, and WCSS should be the y-axis, where it exactly has 15 values. Yeah, so this will iterate here like a loop. I hope you got the point. Now let's make it look good. Let's put some title, elbow method, then plot dot x label, putting some label for the x-axis, that is number of clusters, and y label is WCSS. Yeah, and finally plot dot show. Yeah, now let's execute this all together. Yep. So this is our graph. This is what we wanted to see. If you check the whole thing, you can see there is this fluctuation in 4, I think. Yeah, so the number of cluster, the optimal number of cluster here should be 4 according to this problem, according to this particular problem. Yeah, so we are done. We don't need this part anymore, but we'll keep it anyway. Yeah, now we'll head towards real K-means clustering. Yeah, now again I am going to initialize the K-means variable with some new combination. Yeah, this time the number of cluster is going to be 4, just what we got from the elbow method. And then the init part is yet the same, KMeans plus, and also the random state remains the same, which is 0. Yep. Now what we're gonna do here, we're gonna take a variable y, and here we'll try to store what instance or which instance belongs to which cluster. As I have mentioned here, the number of cluster as 4. What scikit-learn will do, it will label the clusters as 0, 1, 2 and 3. So when we generate the value of y, we generate it in a way which provides information like which cluster, which instance belongs to cluster 0, which instance belongs to cluster 1, and so on and so forth. Yeah, and that's very easy. You just write the variable dot fit predict, yeah, and you feed it with x. Whatever you're doing over x. Yeah, so now let's execute these 2 lines. We don't have to execute these lines anymore because we are done with this part. We don't need it anymore. So executing these 2 lines. Yeah, now let's check the variable explorer here. So the first instance, it belongs to cluster number 3, the second one belongs to 1, the third one belongs to 1, the fourth one belongs to 2, and it goes on. Yeah, but this is not the way, this is not the proper way of visualizing, this is not the proper way of understanding, because we have 10,000 data and it's not very easy. So somehow we have to make it look even more simpler, from where we can extract some information. It can be some statistical value, it can be some graph visualization, and for now we'll go through graph visualization using plot method. Yeah, so we have 4 clusters here, so we have to put all of those in a single graph. For that, what you do, scatter. Here you have to provide several parameters, where the x-axis is going to be x-axis. I think when y, because y have all the values, so when y is equal to 0, 0, yeah, and the y-axis going to be y is equal to 0, 1. Yeah, so what we are doing here, we have x, and inside x we are trying to fetch some structure. So this 0 and this 1, these are the index of x, as we have only 2 index for x. So whatever value has y as 0 in index 0, and whatever value has y equals 0 in index 1, we want to plot them in x-axis and y-axis subsequentially. Yeah, and now we have some other parameters to put here, like s is equal to 25. This is the zoom level of the plotted data, or the plotted data points. Yeah, and then c equal to red, let's say, and we can also put some label here. Let's keep it as cluster 1. Yeah, and we do the same thing for other 3 clusters. So y is equal to 0, it has to be 1 here, 2 here, and 3 here. 1, 2, 3, and let's say this is we have other colors as well. So it's blue and yeah. All right, so also we want to figure out the centroids of each cluster, and that is also possible. We have the clustering variable KMeans here, and using that you can find centroids as well. And that is little complicated to remember for now. KMeans dot cluster centers, and the index for 0 and 1, because we have 2 dimensions here, so it should be all rows and column 0. And here KMeans dot cluster centers, all rows and column 1. Yeah, should be okay. And here color is going to be yellow and label is centroid. Now again some formalities here to make the visualization more understandable. Yeah. Balance versus estimated salary. Okay, let's keep it KMeans clustering. Then we have in our X label, whatever comes first in this index is going to be X label here, and that was balance, I think. Yeah, balance. And here we have to put estimated salary in dollars. Yeah, so we are almost done. Yeah, so we are ready to execute from this line up to this line. Let's see if we get our desired result or not. I think something went wrong. Okay, 0 1 2 3 0 1 2 3 0 0 1 1, and that's fine. Let's check these lines. So basically I forgot to convert our variable which is containing these attributes. We have to convert it to numpy array. Yeah, because these parameters, they're accepted as numpy array format. So I forgot to put dot values here, my bad. Alright, so things should be fine now. Let's execute from the beginning again, from import up to this part, because this part is no more required. Yeah, it's done. From here to here, let's see. So here we have the proper visualization of our generated cluster, where you can see we have 4 group of clusters and each of them has a centroid here and here. So let's analyze the first cluster, which is the red one. So in this particular group, the balance starts from 60 or 70,000 and it lasts up to 0.2 million, yeah, or 0.3 million, and their estimated salary is restricted up to 0.1 million, not more than that. So this is the group. You can say they're pretty legit. They have average estimated salary, and their balance is also not very high but not very low as well. Yeah, some of the members, they have high salary, high balance though in their account, but if you consider the average term, they have quite handsome balance in their account, and they have good salary as well. Yeah. Now let's talk about cluster number 2. I think they are the most rich person in this bank. They have quite similar balance range like cluster 1, but their estimated salary is quite high. Yeah. Now if you consider cluster 3 and cluster 4, in point 0 in balance, there's a line. So there are some customers from cluster 3 and cluster 4, they don't have balance in their account. But if you consider this point, this guy, let's say there is an individual in this point of the straight line, and this guy has no balance in his account, but he has 0.2 million estimated salary. Yeah, that is pretty illogical, but that can be some case, like let's say he had a lot of money, but recently he had to transfer all of his money into some other bank account, or he had to transact all of his money to buy something. This could be anything, right? But we are trying to generalize, and in terms of generalizing, this is such a bad pattern. This is some pattern we don't want to come up with, right? So though it is being included in the cluster number 3 and 4, but we really want to exclude this part, don't we? So let's say this is a noise for this cluster. And also if you consider other members of this cluster, they are not very dense, but let's say up to this boundary of this cluster and up to this boundary of this cluster, they maybe like make little sense as cluster member. But if you consider this straight line, this is far away from the actual points belongs to particular cluster. Yeah, so this is what we want to reduce, and we'll talk about it in next coming tutorial, dbscan, where we erase or we remove these kinds of noise. Yeah, so this group, like cluster number 3, they're actually not very rich. They have salary starting from like 20 or 5,000, or starting from 5,000 to apparently 0.1 million, but the average salary is quite low if you compare this with this group and this group, and also they don't have much balance in their account. Yeah, and then again, if you talk about this cluster, they have high estimated salary but very low balance compared to this cluster and this cluster. Though cluster number 3 and cluster number 1 apparently have the same range of the estimated salary, but still, yet if you talk in terms of balance, they are far away from each other. It only has up to 55 or 60,000, but in terms of cluster 1 starts from 60,000 or 55,000 and goes above 0.2 million or 2.5 million, and here the density is quite high, so the average should be something between 1.3 or yeah, should be at this point. Yeah, and also we have quite legit centroids for cluster 1 and cluster 2, but here the centroid points, they doesn't make really good sense because we have a bad noise in this part. Yeah, so I think this was all for today, and note that this was not a Python programming tutorial, of course. So if you really want to understand what actually went on with the syntax, you need to have at least basic syntax knowledge of Python programming language. Yeah, so I'll see you next time. Until then, enjoy machine learning.